Guys, this is Taylor here, and today we are solving third question of Biweekly Contest 165. So its name is Generate Scheduler. Let's quickly read the problem. So you are given an integer and presenting n teams. You are asked to generate a schedule such that each team plays every other team exactly twice. Exactly twice. Okay. Once at home and once away. Okay. There is exactly one match per day. The schedule is a list of consecutive days, and a schedule I is a match on day I. Okay. No team plays on consecutive days. Return a 2T integer array schedule where a schedule of I of 0 represents the home team and schedule of I of 1 represents the away team. If multiple schedule meet the condition, return any of them. If no schedule exists, then exists that meets the condition, return an empty array. So what is given to us? We have been given n teams. Okay. So let's say n equal to 3, for example. So we have been given 0 team, 1 team, 2 team. 3 teams are there. Now every team will play exactly 2 matches with each other team, with every other team. So what are the possible combinations? We can play 0 versus 1. We can play 1 versus 2, and we can play I think 0 versus 2, right? These are the three combinations that I can play. Now 0 versus 1 will be, I can have a 0 comma 1 here or 1 comma 0 here. So like what is the thing? So 0 is at home, 0 it is away. So we have been given this thing exactly one match per, okay, each time play every other team exactly twice, once at home, once away. So this is once at home, once away. Okay. And for one as well, once at home, one away. Okay, super. Now one versus two will be something like I can play 1 comma 2 or 2 comma 1. I can play 0 comma 2 or 2 comma 0, right? So this is the whole condition, whole question given to us. We need to play, each team will play with every other team. So 0 is playing with 1, 0 is playing with 2. We have written this: 0 playing with 1, 0 playing with 2. Now there are two possibilities. One time 0 will play at home, 0 will play it away. Okay, this is the thing. Now if we list these things down, so I am having all these things. If I make array some kind of this thing, so I'm having all this thing. Now what is given to us? Now we have like on each day only one team will play, only one match will be done, not one team, only one match will be done. So let's say I have started with 0 comma 1. Okay. Now next day I can't play this one because same teams can't play together. So next match would be this team and this team won't be there. Okay. So from this combination it's not possible. But let's say if 0 comma 1 comma 2 comma 3 comma 4, let's say we have five teams. Okay. So on first day I can play 0 comma 1. On second day I can like what two teams can play, I think 2 comma 3 can play, right? On the next day 0 comma 1 now can participate. So 0, I can either write 1 comma 0, that will also work. So I hope you understood. So what is given to us on next day these two teams will not be able to play. On next day these two teams will not be able to play. Okay, so we need to change teams, we need to change both of the teams. Okay. And we need to, like, first of all create all of the combinations, one at home, one at away. We need to create all of the possible combinations, and we need to place them, if it is possible, we need to place them in order, so that on day one which team can play, day two which team can play, with day three which team can play, considering this condition. Okay, on next day same team can't play. I hope question is clear to you. So how we can solve this problem? So if you see the constraints, just to give you some hints, so constraints are 2 to 50. So constraints are very, very small. That means maybe some recursive solution, or maybe you can say some brute force solution they are expecting us to write, right? So maybe some recursive and brute force you can think of. So if you see the hints for this question, they are talking about to solve it greedily, or some solutions are there in the solution section which were using randomization to solve this problem. And they are like in future they are telling to use backtracking as well. We can solve this using backtracking as well. and there are a lot of solution, but the very best solution that I found out is basically what we can do. So let's say, for example, my array is empty. Array is empty. Once I have generated all of this, once I have generated all of these pairs, so generation of these pairs is not a tough task. What we need to do, we need to generate how we can generate. Let's see. So let's say if we have 0, 1, 2, 3, let's say for example, if we have this, so what we can do, I can start, I can go here. I will let 0 play with 1, I can let 0 play with 2, I can let 0 play with 3. And I will do opposite. I will do opposite. 1, 0, 2, 0. Or let's not do it. Let's not do it. In loop, how we will be doing? Let me tell you. So I will be doing like this: 0, 1, 0, 2, 0, 3. Now I will be doing next. I will start from 1, 1, 0. Now 1, 1 I am skipping. So here you can see 0, 0 I have skipped. Here I am skipping 1, 1. So I will put a 1, 2, 1, 3. Now for 2 I will write this is for 0, this is for 1, now this is for 2. Okay. So 2, 0 I will write, 2, 1 I will write, but 2, 2 I will not write. So 2, 3 I will write. Okay. Similarly, you can run two nested loops. Let's write pseudo code for that if you have any doubt. For I equal to 0 to n minus 1, yes, n minus 1. For j equal to 0 to n minus 1 again. If I not equal to j, then I can maintain some all pairs equal to empty list, empty array, and I can append all pairs dot append I comma j. I can do something like this. So something like this I will be able to generate. I will be able to generate something like this. So for 4 and 5 there are a lot of combinations. We are not running writing all of them, but the idea, I hope you got it. So we will be having pairs like this, right? So once we have pairs, right, what we'll be doing, so solution is really simple. What we are going to do is, we are not trying to go in recursion. We are like what most of the recursive solutions is doing, like some of them are using randomization, some of them are able to pick the element. So they are picking the element 0, 1. Next time they are trying, can I pick 1, 2? Can I pick 2, 3? Let's say 3 is here. Can I pick 2, 3? If they are able to pick 2, 3, then it's fine. Next time they are trying to pick something else. And if they are not able to pick, they are basically removing the last added element and they are trying to pick something else. They are doing like this. So they are going to depth recursion. Then if they are stuck, if they are stuck, so they are backtracking. So that was one of the solution. Now before diving into the solution, one thing to observe is for n equal to 4. Okay, n equal to 4, for n equal to 3 and n equal to 2, n equal to 2, solutions are not possible. Okay, so if you see, this is n equal to 3, right? Once we took 0, 1, is it possible to take 1, 2 here? No, because 1 is repeating. Is it possible to take 1, 0? No, both are repeating. Is it possible to take, I think, 0, 2? No, 0 is repeating. So it's not possible. In case of 4 as well, na? So 4 as well, 0, 1 and 2, 3 you can take. But if once you generate few pairs, you will be stuck in future. So you can directly say for n equal to less than equal to 4, answer is not possible. So you can directly return an empty list, empty array, whatever you say. For n equal to 5, from n equal to 5 to 50, answer is possible. Answer is possible. Now what we'll be doing, the approach to solve this problem is, we'll be generate all pairs. Okay, using this pseudocode, we'll be generating all the pairs. Let's say all pairs are present here in these variables. All pairs are present in this array. Okay, now what I will be doing, I will initialize my answer equal to -1, -2, -3, -4, something like this. I will initialize my answer. Okay, now what is the next thing I will be going to do? So I am having a lot of pairs, right? Let's pick some of them. So let's say I had generated those pairs, I think here. This is for n equal to 5. So, super. So, I have added this -1, -2, -3, -4 as a helper variables. We will understand why I have added it, why I have added this, and once we are going to return the answer, we will remove this first and last element. So the resultant will be this array that will be getting. Super. Now, what we are going to do? We will try to pick every element. We'll try to pick every element and try to put this element, put this 0, 1 in the resultant array if we are able to do it. If we are able to do, if rules allow us, we will be going to do that. So my current array, current answer state is this. I will go to 0, 1. I will check. Can I put this here? Can I put this here? So I will check. I will put a 0, 1 here. Okay, 0, 1 I am putting here. I will check. Is 0, 1 present here? No. Is 0, 1 present here? No. So my team, I'm able to I'm able to put this team here because this team and neither they played previous day and nor they are playing in the future day, in the next day. So I can definitely put it. So my current answer state will be something like this: -1, -2, I think 0, 1, and -3, -4. Super, super. Next thing. So this is done. This is done. I am here 0, 2. I will check. Can I put 0, 2 here? I think no. I think no. Why? Because 0 is present here. 0 can't play consecutive days. Can I play 0, 2 here? No, I can't. So what I'm doing, carefully read. This was my current state. I was checking in middle. Can I put this here? Now in this state of answer, I'm checking, can I put this here or can I put this here? Because these are the two possible places where like either I can put here, either I can put here. What I'm trying to do is I'm just trying to pick a team. I'm trying to pick the team. I'm able to place the team. I am trying to place a team. Can I place it here? Can I place it here? So this is, you can say, a greedy way or a brute force way to do this, and this will give you a correct solution. So can I place a 0, 2? So you can see 0, 2 I can't place. 0, 3, 0, 4 you can't place. This you can't place. Even this one you won't be able to place this all things. But as soon as you reach 2, 3, you will be able to place it. So let's place it. Let's try run for some test case. So 0, 2, 3 I am able to place it, I think, here. Super. So my current answer state would something look like this: -2, -3, -1, -2, 2, 3, 0, 1, and -3, -4, -4. Okay. So let's say for example, just for example, we will try to do this thing for every possible pair. Let's say I'm able to put for example this one as well. So just a hypothetical example. Let's say this is done, this is done, this is done, this is done. This pairs are done. So what I will be doing for this remaining pair. So these pairs are remaining. This is remaining, right? This is remaining. This is remaining. So what I will be doing for these pairs are, I will store them in a temp array. Okay, I will store this temp remaining pairs in this temp array, and the next time what I will be doing, I will be, so for now, like after 1, 2, 3, 4, 5, after this 5, after putting this 5 pairs in my answer array state will be correct, right? So what I will be doing, I will be again trying to put, I will assign this temp array to my all pairs array. Okay, all pairs equal to temp. I will be doing something like this, and the next time I will try to iterate over this remaining elements. Okay, over this remaining elements I will try to iterate, and I will try to put them in its correct position. I will try to put them here, here, here. So, like, if so, one thing we are sure that for n equal to greater than equal to 5, answer is possible, right? Answer is possible. So I will be definitely able to put this. I will definitely able to put this. Every pair I will put. I will be able to definitely put at some correct position. So, uh, like just considering that as an assumption, I will try to put every pair. I will try to put every pair in answer if I'm able to put by following this rules. This like left and part elements are not same. just considering this rule and just considering the assumption, I will try to put at every place. If I'm able to, then well and good. Otherwise, I will store in temp array. And once I'm like iteration is done. Whatever the remaining elements, na, I will try to again assign it to all pairs, and I will try to again do the same thing. So once we write the pseudocode, everything will be very simple, very easy to understand. So what let's try to write pseudocode. I think problem implementation is very easy. Just you need to think of this way. So what we are doing, we are just trying to put answers. We are trying to check whether the remaining answer, this was remaining, right? So can we put that here? If yes, I will put that. Otherwise, can I put that here? If yes, I will put that. Otherwise, I will assign it to temp. I will assign it to temp, right? I will try to see, can I put this? Can I put this remaining element here, here, where I can put actually? That's all, nothing else. So all pairs I will be able to generate using the pseudocode that we discussed here. If you missed that part or you want to revise, so what you are doing, you are starting from 0 to n minus 1, 0 to n minus 1, and let's say 0, 1, 2, 3, something like this. We are trying to go for 0 to 1, 0 to 2, 0 to 3, 1 to 0, 1 to 2, 1 to 3. We are skipping same element. So if I not equal to j, then only we are generating the pairs. We are appending in all pairs. Once we have all pairs generated, what we can do, I can check while length of all pairs is greater than 0. And first of all, if n is less than 5, or you can say less than equal to 4, I can definitely return an empty array, because I know one thing for sure, that that answer is not possible. Now, uh, okay, while length, what I will be doing, I will try to go to each pair. I will try to go to each pair. So for I in, okay, for I equal to 0 to length of all pairs, I will go something like this. Now what is the next thing I need to do? I will assign x comma y equal to all pairs of I. Okay, so that way I will be able to assign this number as x, this number as y. Now what is the next thing I need to do? For j equal to 0 to, I think, current length of answer minus 2, including this. So what I'm trying to do here, basically, let's say current answer state is this, right? For this, I'm having only one option, only zero, only at this index I need to check, right? So I'm having only one option. So that's why I'm writing minus 2. So I will be running only for 0. So let's say our answer state is this. So I will be running two times, right? Two times only. So for 3, I am running two times. One is 0 time, one is 1 time. Like for, I'm starting from 0 and my length is 3. So I'm running till 1. So for 0 I will run, for 1 I will run. For 0, this place, for 1 this place. So I'm running loops two times. So I hope you understand why I'm writing my length of answer minus 2 here. So once we okay, once we have this, we are able to find out this place. We will write some function def allow at I. So it will take I, basically the index, or maybe j, you can say, because we are using j here. So we will pass j here and current answer state here. And I think x comma y, the number that we need to pass. So we will pass these things here. If allow at j, allow at j is telling us true. So what I am passing, I will pass this j here first of all. Second thing, my answer. Third thing is x and y. Okay. So I will implement this function. What this function will do? That function will check if, let's say, this 0 is given to me. So for this place, I am considering this left index. If 0 is given to me, I will check, can I place x comma y here or not? So that function will tell me. If I am able to place x comma y, it will tell me true, otherwise it will return me false. So just in case I am able to place it, I am able to put it. So what I will be doing, I think I can. answer dot insert at j at index. I think not j exactly. I think j plus one. J plus one. Why j plus one? Because for this place, I am considering zero. Ignore this. For this place, I am considering zero. For this place, I am considering one. So I need to put at this place, right? So j plus one. That's why I'm doing j plus one. Okay. So I need to append this j plus one, and what I need to append x comma y. If this is telling me to, we will implement this function shortly, but I hope you understand. Now, if I'm not able to put it right, so what I can do, I think I can append this in temp array. Temp dot append, I can append this x comma y. And once all this iteration is done, in the last, I will assign all pairs to my temp. So whatever present in temp, that will go to all pairs for the next iteration. So in the next iteration, maybe I will find out the correct place for the remaining elements. So these were the remaining elements, right? So in the next iteration, I will definitely able to find out the correct position. So let's say this I was not able to place in between this and this, but this I can definitely place. I think between this and this, right? This and this I can place. So in future, I will find out the correct place for this, right? I hope you understand it. So once we are done with all these things, we can definitely return our answer. But before returning answer dot pop zeroth element I need to remove, and I need to remove the n minus 1th element as well, because we had added some helper pairs in answer, right? These were the two helper pairs. So we need to remove this part, and then we can simply return our answer, return answer. So I hope you understood this, what we are doing. So let me quickly implement this part as well. So what I'm doing, so I will put x1 comma y1 equal to answer of I, and x2 comma y2 is answer of I plus 1. I will make a set. Okay, I will make a set. If set of, if I will write something like this, if length of set of this x comma y and x1 y1, x1 comma y1 and x2 comma y2, if length of this set is equal to 6. Why I'm doing like this? If all these six pairs are unique, that means the length will be 6, right? Because this is set, this only allows unique elements. If this is the case, then what I will be doing, I will be returning a true. Return true, otherwise I can return a false. So I hope you understood the solution. And just to let you know briefly again what I'm trying to do. I have generated all of these pairs. Now I am trying to check whether I put this pair here. If yes, I will put it. Can I put this pair here? No. So I will add it in temp array. Once I have it in temp array, once iteration is done. All this iteration is done. I am reached here. I will assign this temp array to all pairs. So all pairs I'm having the remaining elements. Remaining elements will be present in the temp array. Once I'm having remaining elements and answer with these updated values at its correct position, I will again do the same thing. So this will give me definitely a correct answer. Let's try to implement this code. Code is not tough. So let's quickly implement this part first of all. Def allow index. Let me put it a correct name. Index. So I and x comma y I need to pass, and answer I need to pass. I will check x1 comma y1 I can get from answer, x2 comma y2 I can again get from answer I plus 1. So we don't need to write if else conditions, if whether the answer is empty, whether answer is having one line, nothing else, because we are using some helper variables to avoid these things. So these are best practices to write in like industry level code. Once I'm having like this, if length of set of this x comma y comma x1 comma x2 comma y1 comma y2, if length is equal to 6, in that case I can definitely return a true, otherwise I can return a false. Super. My function is ready. Now what I need to do, I need to generate all pairs. All pairs in this code is very easy. For I in range till n I will go. For j in range, till n I will go. If I not equal to j, I will all pairs dot append I comma j. Simple. I have generated all pairs. Now what is the next step? I need to go till while loop. So first of all, I will assign empty answer, not empty. I think -1, -2, and let's use tuple so that Python tuples are a little faster than this normal lists. So okay, one important thing. I think we made some typos here. So this should come. This should not be like this. We can make a inserted flag here, inserted equal to false. If we are able to insert it, we can make it true, okay? And we can immediately break the loop. And we can check if inserted equal to false, then only we will be able to add it in temp dot append x comma y. So why this is so? In this we are trying to find the correct position, right? So if we are not able to insert at 0, 0 at the first position, we will try to put it in another correct position, right? So we should definitely check all of the correct position. If we are not able to find, if inserted is still false, then we are going to add it in temp. So here I made some typo, please ignore that. So if we are able to find out the correct position, I am making inserted flag as true, and I'm breaking the loop. And if inserted is still false after running whole the loop, that means I'm not able to find correct position of that pair. So I'm adding it in. Okay, super. So let's try to implement this part. While length of all pairs is greater than 0, what I need to do, I think I will go for I in range length of all pairs. I will take the x comma y from all pairs. Superb. I will have a temporary initialized. Once this is done, what I need to do? I need to find out the correct position. For j in range, I think I will go from 0 to length of n minus 2 include. So this will we need to make it -1 by 2 just to include the -2th element. So in Python range function, it will exclude the last element, right? So that's why I have written -1. But if you write in C++, Java, JavaScript, you need to run loop till n-2th. Okay, n-2th. This will include n-2, but it will exclude n-1. So once this is done, uh, I will check if I'm able to if allow at index at jth index, can I put x comma y in answer? If yes, then well and good, I can break. But before breaking, I can insert in my answer at j+1 position. We saw in code why we are inserting at j+1. Next +1 is the element that I need to insert. I can make a flag variable inserted equal to false, and I can make it inserted equal to true here. If I'm not able to find if inserted is still false, then I will assign into temp, and whatever elements I am not able to put, I will all pairs equal to temp. I will again assign it to all temps. I will try in the next iteration, because in the next iteration definitely I will be able to assign some of them. Now, and after this I can remove the first and the last element of answer, and I can return the answer. Why we are returning popping? Because these are these helper variables. Okay, super. Let's try to run this and see whether it is working fine or not. Okay, it is working fine. Let's try to submit this. Okay, it is working fine. So I hope guys I'm able to explain you this interesting greedy problem, which is having lot of solutions, but this is the best possible solution, which I can explain you in the easiest term. This is a most easiest solution. What we are doing, we are just trying to put answers in its correct position. We are checking whether we can put here, here, or here, or maybe we will store them. Whatever we are not able to put, we will store them, and we are again trying in the updated answer. So thank you very much guys for watching this video. We'll meet in the next one. Thank you.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us.